Hello, New World Optimist and your viewers. My name is David Oker, and New World Optimist had asked me to do a video interview, if you will, um, of my interests in transhumanism, where how I came up with my ideas. Um, yeah, I thought I'd talk about um, the well, why I agreed to do this. I don't necessarily think that doing this is going to change the world. uh, I don't think it. I don't think the majority of the population will ever hear about it. um, Maybe it's good for review. Um, I just when I think about, I find that I mean, recently I came across a website that shows the world population as it's growing, um, and you know, current world population is about it's 4 billion, or it's 7.6 billion. Um, the last time I had checked, the world population was 4 billion, and I had I had I had grown up thinking that I would live to see the world at maybe 5 billion, or you know so 7.6, I mean, billion right now is a population explosion that is so large. I mean, I've always, I know that, I say back in high school times, I've always said that there's a new generation born every 15, uh, 20 years, and there's so much knowledge out there that every generation, every 15, 20 years, they're going to cut out what they think is not relevant to their life, and so I know that during my time, for instance, Jacob Bronowski is pretty much cut out. I remember going to bookstores and Walden Books long before Barnes and Noble and Bookstar and other huge bookstores. They had a small section on science. They had one row science books, and there was always a Jacob Bronowski Son of Man. I remember taking a look at it real quick and thinking, he's some sort of amateur historian, science historian, not much of interest there, putting it down and not really thinking about it much. Um, so so I don't think, I can't imagine that I don't think that I can possibly touch that many people's lives by the time the nano era comes. Um, Nano era is one of the main technologies that you would need for transhumanism to happen. Uh, uh, and I've seen some developments that DNA nanotechnology could make for a primitive nano manufacturing capability by I think probably before this year is out. Somebody came with a brilliant idea of making an electric uh, motor out of DNA, and this allows them to speed up the placement of atoms and molecules, and they still got some work to do. But you know, what's remarkable is I've also seen some developments on scanning tunneling microscopes. This is one of the original possible enabling technologies to make nano manufacturing happen. It kind of gave up on it a little bit. There was a problem with the chip crashing into the sample and destroying whatever was there. There was also, they solved that by a negative feedback loop. Somebody finally figured it out. There were some others. I think there was two other developments I thought were interesting. Shoot, can't remember, but as of when I'm doing this, I might not be the freshest on everything. But right now, we're pretty much living in an AI revolution. I mean, AI has really been blowing up over the last couple of years. They're kind of hoping that AI could be used to help develop nanotechnology. I know there was I think it's Oak Ridge computing, the supercomputing group that is able to crank out neural nets for DeepMind artificial intelligence on a daily basis. Before that, it was months and years it took them to develop them. So you know, we're living in a time when we're about to get into a lot of the technologies to make transhumanism possible. And well, anyway, New World Optimist wants me to try to give some idea of my origins of how I came to these things. I first hit on Eric Drexler's nanotechnology back in like 88, 89. And I thought it was kind of interesting how when I first saw the book, once again, it was just a small, not even a Walden Books bookstore with, you know, a small science section that had like one row. That's the way I remember it, the science books. And it started out with nature, you know, books not exactly even about theory of evolution or anything. And there was Eric Drexler's Engines of Creation, and I remember when I first picked it up, I didn't think much of it at the time. I remember how long it took me now to get back to it, but I remember the way I remember a couple of years. A couple of years, I came back and the book was still there. Nobody had bothered picking the book up. So I managed to pick it up, and I don't know why. I know that the way I see it is that I associated advanced technology in the future of humanity, you know, as space exploration and colonization and rockets, and that was futuristic technology. And I didn't see how cell biology had anything to do with future technology. But when I came back, something hit me there a little harder. I can't remember now. But I picked it up, and I read about, you know, the life extension in there, and obviously the space rocketry, and the artificial intelligence. You know, the increase of pace of technological development. If you have now technology powered by artificial intelligence, you can create so much technology. You create life extension and solve a lot of biological problems. And so that's I had probably a natural understanding of transhumanism right there. I remember I picked up on an Extropian magazine sometime. I paused the video because I remember I knew where my first and only copy of Extropy magazine. I could probably date, yeah, 94, 1994. So that's the so I was certainly cognizant of transhumanism back in 1994, right before I went in the Navy. That's kind of interesting. So, but um, but I had a lot of other interests. Chaos theory was kind of big then. I remember reading James Gleick's Chaos. I read some other books, Turbulent Mirror, about chaos theory. They're trying to suggest a scientific revolution, not just a new science, but a new scientific method. And I didn't totally agree with that, but I think it influenced me to have another idea about transhumanism. The Extropian, if you will, transhumanist idea is to upload yourself into a nano-crystal computer, and that's it. I mean, I have I remember developing it, thinking about the second law of thermodynamics and stable non-equilibrium thermodynamic structures, and coming up with some different ideas about transhumanism, that of open systems, the difference between closed and open systems, and in a closed system where you're not having any more energy and matter flowing in. If you just let it sit, it dissipates all the energy as electromagnetic radiation eventually, and cools it down and to a homogeneous state, and maximum entropy. But Ilya Prigogine basically won a Nobel Prize in 1977 for his work on stable non-equilibrium thermodynamic structures. Showed that if you have an open system, a flow of energy and matter, that you could sustain your dynamical structures. And people will argue that that's not that life is something more than just dissipative structures as defined by Ilya Prigogine. I'm tempted to agree. I like the autopoiesis theory. That really, you could say it's autocatalytic set, kind of like Stuart Kaufman's ideas that if you have a sufficient diversity of molecules that make each other, about 50%, that they will self-organize into a chemical cycle. Chemicals that make each other in cyclic ways. And so so my idea is essentially that. I remember thinking about how multicellular life isn't exactly structured like a bacterial cell, which is much more like these chemical cycles. I mean, the arm doesn't make the leg, and the leg doesn't make the head, and the head doesn't make the arm, and so you don't get these. So we have, so multicellular life has death. Death was kind of invented by multicellular life, and so we go about sustaining, keeping ourselves going in a sexual way, in a different way. We invented sex, and we invented death, and so well, getting back to the cells. Cellular life is like these chemical cycles they have because of a flow of energy and matter into them. They can sustain for a pretty long time. In fact, it was a revelation that bacteria have been found to go back to millions of years in Greenland glaciers. They can keep going. They're kind of these perpetual motion machines. If they can keep the conditions the same, they can just keep on going. And when multicellular life was invented, well, it wasn't structured that way, and so they were they created a little more of a closed system. So they didn't have these feedback loops to quite the same way to keep themselves going. And I had this idea that humanity appears to be the first species that has gone down a road to create, to use knowledge as a way of creating technologies and learning about, scientifically learning about the universe and themselves to keep themselves going. We've done a certain amount of life extension. We live a certain amount longer than our ancestors of. Some people would say a couple hundred years since the beginning of the Industrial Revolution, maybe even the Renaissance. I'd go back to maybe the Bronze Age. People could live for a bit longer than 30 years, which would be the average for the cave painters and earlier, Homo erectus. The longevity was probably 30 years or so. Not that everybody did. In the Bronze Age, all the way up to maybe Renaissance to Industrial Age. It was still, the life expectancy was still 30 years or so, and it's hard for people to develop new thoughts and pass them on without dying first. And of course, with artificial intelligence and nationology, it's probably the viewers that I'm going to see, not the majority of the 7 billion, 7.6 right now as I'm speaking. Only the people that have heard of transhumanism are probably going to hear about this. The nationology and artificial intelligence is developing within our lifetimes that can possibly extend human lifespans a couple hundred years. And then if you live that long in a nano era with artificial intelligence powered nationology, you probably extend the human lifespan to thousands of years. And if you live that long, you could keep extending it. You could probably live to be able to extend your life by means of the feedback loop completing, using science technology as completing the feedback loop that was broken when we became multicellular life. That's my transhumanism idea of keeping our dynamical selves going. I don't mean to become a nano-crystal computer, but to keep our biological cells going by means of science and technology as the missing feedback loops. That's my idea and of transhumanism that I thought I'd throw out there, which I never heard. I pushed it a couple tried here and there, but you know I don't really hang out with transhumanists, believe it or not. My interests actually, the interest that I've focused on has been more about nature and origin of mathematics, and that goes back even before I picked up Eric Drexler's engines of creation, way back in when we were living in Wismar, White Sand Missile Range. I remember, I might have told you all this already, but we'll go back again real quick. That I remember, I vividly remember, a dark night coming back from Las Cruces. We would have to go to Las Cruces to go to an actual market or a shopping center, because there was nothing like that in White Sand Missile Range, which is south of Las Cruces, New Mexico. And I was doing some algebra at the time, and I was struck by the mathematics, and my interest in mathematics was more of the origin and nature of the mathematics. Of course, I'd like to learn mathematics, and right now I'm kind of what I would call a John Stilwell level. You know, if you Google John Stilwell, he's done a lot of technical histories of mathematics. He's tried to connect ancient to modern mathematics a lot more beyond what you would normally get in high school. Abstract algebras and topology. He tries to find ways to introduce that, make it accessible to the people and connecting it from the beginnings of mathematics. I don't want to say too much more about that right now, but that is still kind of where I am. But I believe that I have learned quite a lot about the nature and origin of mathematics. I should maybe comment real quick. Then you probably think I'm going off on a side issue about transhumanism, and I would argue that for me, transhumanism, what I was interested in Eric Drexler's nanotechnology and transhumanism was to be able to live forever and do mathematics. My interest is to do science and mathematics and live for free. If you read Eric Drexler's Engines of Creation, he explains that to create nano manufacturing systems, that's what I would like to call it. You kind of have to automate it. You can't have people. You can't have your hands actually hold individual atoms and arrange them all. You have to automate the system. You also have to have quantum chemistry simulation software, and you have to put that software into the nano computer or some computer that can talk to the nano machines to be able to, so the nano machines know how the chemistry works. So, I mean, that's one of the astonishing things about nano manufacturing that maybe doesn't always get talked about by people that want to talk about Eric Drexler's ideas there. He talks about it, but I thought I'd stress that a little more because when you do that, you essentially have an automated system that can make anything you want, and you essentially live for free, and you're free to study and play music and or do whatever your hobby is. And so that was what was great. Was one of the things I thought was great about nanotechnology, inspiring to me, and continuing into transhumanism was, for me, transhumanism is about going into the future, a scientific future, an intellectual future, and the ultimate of intellectualism to me was mathematics. And so I want to continue talking about what I found out about mathematics. I think I know I did find Reuben Hirsch and Philip Davis, the mathematical experience. It's not really. It is a little bit about trying to understand the nature and origin of mathematics, but it only gets into understanding how abstraction works, which is fine. Abstraction is and idealization is real easy. It goes back to Plato, and some people that like to try to talk about the nature and origin of mathematics will comment that the philosophy of mathematics hasn't changed since Plato, where he talks about how there's concrete material world and there's abstract mathematics, and talks about idealization. Idealization is where when you're trying to solve a problem, you only want to involve properties of the phenomenon that are relevant. And like I remember James Gleick kind of talks a little bit about this in his Chaos. He's saying, well, you think you don't need to talk about, some electron conducting on Mars somewhere, that it won't affect what's going on in your experiment here on Earth. And for the most part, and usually that is the case. You want to make a closed system, and you want to be able to establish the variables of the experiment, and that the concepts involved transform into each other within that closed system, and mathematics can do that, and that's idealization. Mathematicians can distinguish between abstraction and idealization. Some people will just call idealization abstraction, but there's another type of abstraction which is kind of about analogous structures, where there's analogous concrete manifestations or structures to a form, an abstract form that is the same. The famous, quick, simple example is 2 oranges and 2 apples are concrete examples of the abstract concept of the number 2. If you have a point and another point, and you draw a line, you have these 0-dimensional points all in a line, and there's many examples of A to B You can be traveling from San Diego to Los Angeles. You can imagine a abstract line between those two. There's a abstract line uh, um, between the diameter of a circle. You can imagine abstract line between the length of your foot to your torso, and so on and so forth. So both geometry and number are abstract concepts. Um, and that's where most people stop in their understanding of the nature and origin of mathematics. I like to point out Suzanne K. Langer's Introduction to Symbolic Logic. She's more famous for a book about the theory of aesthetics and art, art in a new key or something like that. She tries to talk about symbols as a way mankind thinks. I haven't read the book actually, but I have read a book by Ernst Cassirer, which she translated, which talks about how forgetting I think it's called Language and Myth, like that, where he talks about the analogy between mythology and language and mathematics, that they have a common property of analogy. And Jacob Bronowski is another guy. Not sure if I brought him up already, but Jacob Bronowski talks about is famous for writing Science and Human Values, where he points out that poetry and mathematics share a common property, which is called analogy. Poetry, they call it simile and metaphor, and mathematics, they call it abstraction. And so that's all nice. And once again, Ernst Cassirer talks about mythology and language, and that mythology is also poetry, and poetry is analogy. And so, I remember hoping to maybe derive number from mythology. I got into mythology. I studied a certain amount of mythology. I guess that's not exactly appropriate to talk about comparative mythology. You can go pretty far and talk about some things that maybe not. I don't need to talk about those things here. But the fact is mathematics is a little bit more constructive than poetry. Poetry, they cherish their vague notions. They think that vagueness is the power of poetry, and maybe it is. Mathematics tries to be well defined, scientifically defined. You can argue that mathematical concepts are scientifically defined concepts, where in science, it took a little while for this concept of science to develop, but when people introduce science, they'll point out a Cartesian coordinate system, and that you get a bunch of once again you establish your variables. You keep one variable stable, and you let another variable vary, and you plot the data on on a Cartesian coordinate system, or maybe something more elaborate. And you draw a line, and if it's curved, you do a mathematical operation to straighten it out, and that gives you your formula. And but I would argue that mathematical concepts kind of do that, but in a lot more of a abstraction and conceptual way. Well, I want to get into Jacob Bronowski. His origins of knowledge and imagination. And this kind of gets back to me trying to explain my history of how I came to my ideas. Once again, I had picked up Jacob Bronowski's Ascent of Man book, and I didn't think he was much more than some amateur historian of science. And then my sister was working at a used bookstore up in Los Angeles, and she got me his Origins of Knowledge and Imagination, which I have right here. And so that was different. I mean, I knew right away this was definitely something, a different side of Jacob Bronowski, and so I started reading it, and I found it very interesting. He says quite a lot of new things about the nature of knowledge, and he gets into idealization, and he talks about how Immanuel Kant had a program to talk about how what we perceive of the world is not what it actually is. That if you just take what you perceive of the world at face value, it's often kind of flat Earth. And your initial perception of the Earth is that it's flat, and it takes some observing some curious facts, things like the retrograde motion of the planets. You got to notice the planets, that they're moving, and then you got to notice that they're moving back and forth, and maybe take note of the shifting phases of the moon, and to kind of tease out that the Earth is spherical, and that the Earth goes around the sun and not the sun around the Earth. And this is, he'll point out that Immanuel Kant's program at the time maybe wasn't, we weren't ready for it at the time, and that he argues that because of all the non-euclidean geometry revolutions in the 1800s, and the abstract algebra, and then Albert Einstein's general theory of relativity, and even special relativity, changing. I mean, because before Einstein's relativity theory, we thought that the Euclidean geometry was kind of like a physics of how the shape of the universe, of how the geometry of the universe actually works. And it wasn't until non-Euclidean revolutions of late 1700s, and then obviously culminating in physics with Albert Einstein's special and general relativity, that Newtonian mechanics wasn't as such a finished product, and and Euclidean geometry wasn't the geometry of the universe. Um, that are, you know, that even Newtonian physics and Euclidean geometry was kind of flat Earth, kind of like viewpoint. I mean, it is it Newtonian mechanics is not exactly it's not wrong like flat Earth. It is something that is a theory that developed as described by Jacob Bronowski, which I'm hoping to explain. Well, I mean, let me just say that Jacob Bronowski's Origins of Knowledge and Imagination uh, unifies all these revolutions: the non-euclidean geometry, the Godelian incompleteness theorems, the quantum mechanics, and the general relativity, and how that uh, went beyond Newtonian mechanics and Maxwell's electromagnetic theory. And so, what Jacob Bronowski points out, I'm going to go talk. I'll start probably chapter 2, where he talks about idealization. He points out that we cannot create a theory by including everything. You have to make a cut. You have to make a finite cut, and when you do that, you introduce undefined terms. When with and you have to establish axioms from which which are the basis of your theory. And these theories, these axioms and these undefined terms can only be preliminary. And when you continue developing mathematics and science, you define these things where previously they were undefined, like mass for Newton was an undefined term. And with Albert Einstein's special relativity, mass gets defined a lot more. And maybe in the future with quantum gravity, we could define mass again. And he talks about, and well, and well, about those axiomatic systems, mathematicians hoped that they could create a single finite set of axioms that could be used to make a deductive system for all of mathematics and all of science. Kurt Gödel published in 1931 his incompleteness theorems, where he showed that a consistent finite set of axioms cannot prove an infinity of truths, but an inconsistent set of finite axioms can prove an infinity of truths. We'll just talk about the consistent set of axioms that mathematicians and scientists like to mostly play with consistent finite. Some try to make a transfinite axiomatic systems. But the point is that a real scientific theory, and Newton's theory was a real consistent theory, and so was Maxwell's electromagnetism and the thermodynamics of the 1800s were a consistent set of axioms. But they, of course, were a finite set and could not prove an infinity of truths. And so this, what Jacob Bronowski is arguing is that this goes back to idealization and that when we make a finite cut in an infinitely detailed universe, he's essentially hypothesizing that the universe is an infinitely detailed universe. This implies that the universe is infinitely detailed, and that when we make this finite cut, we get these finite set of axiomatic systems. This is where matter stood for a while, and I thought that that was interesting enough. But well, I remember going back in time again and describing where I got my ideas again. I remember there was the Discovery Channel, which was about science at one point, and then it became about craft shows and other stuff, going to used shops, stores, and getting so they made the Learning Channel, and so Learning Channel is going to be about science, and they were showing these connections and the day the universe changed shows by James Burke. And these shows actually go back to 1977, 1978 on the BBC channels. I'm not sure if they were shown in America at that time, but they certainly were around the time when I was first watching these. And I didn't make these connections till much later, certainly till after I had read and digested Jacob Bronowski's Origins of Knowledge and Imagination enough, and I just watch them just because they were very entertaining. Mostly technology, but some science. He tries to make connections between, you could say, politics, social events, and science and technology. And he tries to talk about change. He tries to suggest that maybe not all change happens because of science and technology, but in my opinion, what he establishes is that the genuine changes of humanity come about because of science and technology. Now, I've noted a couple of different types of connections, which I don't think he totally distinguishes. I remember I was watching the Mechanical Universe, and the main guy, I forget his name, is talking about how why the electric static wicks have a spherical ball on top and not a sharp point. And he said, well, that's because King George dictated it. And he said he didn't like that sharp point. That was a little unnerving for him. And so put a ball on top, and that's why you get these static wicks that have a spherical ball on top. And not all, but still. And so you do get these type of things. You get some of these type of connections. But Jacob Bronowski points out a lot of other curious connections, which I find rather analogous to what Jacob Bronowski is talking about in his Origins of Knowledge and Imagination book, he points out James Burt, episode 1 of his Connections, his first Connection series. He talks about agriculturalism and how in agriculturalism, when you clear the fields, you have to worry about fertilization, pest control, and irrigation, and when you establish agricultural civilization, you come up with all kinds of technologies to store the food, to till the land. He actually says that the plow started agriculturalism. I don't know if I completely agree with that. He even says that storing things started mathematics, and that's wrong. But I mean, mathematics there was tally sticks back in cave painter days, 30,000 years ago, and agriculturalism was less than 10,000 years ago. And but it's interesting the way you what I like to call damming up nature, or clearing the fields, is kind of like I'm making an analogy that clearing the fields is like damming up nature, like a hydroelectric dam. You keep the water from flowing, and that powers by potential energy, makes a dynamo spin, and you get these electricity. You get a concept. I'm making this analogy between the way clearing the fields and agriculturalism leads to new technologies as concepts, as like undefined terms of a theory, and creating a finite set of consistent axioms. But of course, they're not the entire story. Agriculturalism creates all kinds of problems of affecting the environment, and with industrialism, it leads to global warming. Some people will point out that quite possibly the Egyptians' agriculturalism led to the Sahara Desert. But anyway, and so you have new problems, and when you solve those problems, you come up with a new finite set of axioms with a new theory that derives the old theory as a special case and proves new theorems that the old theory couldn't handle. Newtonian mechanics can be derived from general relativity, but it can't be derived by quantum mechanics. And that's kind of interesting, because we're trying to make a quantum gravity, because we know that in certain situations like the Big Bang and in black holes, quantum mechanics and general relativity have to combine somehow. But so we know we have to come with a new theory, and so someday general relativity will end up like Newtonian mechanics. But anyway, so I'm Jacob Bronowski's making these new ideas of a new theory of the nature and origins of mathematics and mathematical science. And so Jacob Bronowski's new general understanding of nature, origin of mathematics gives a coherent explanation of the mathematical and scientific revolutions, from the non-euclidiean geometry revolutions to Gödel's theorem, and And I would argue, related to transhumanism, that people don't people will talk about information overload. And I would argue that by seeing if you can find the general viewpoint, you can deal with information overload. And a transhumanist, um, I mean, my idea of transhumanism would be that you are able to live essentially forever, that you can make whatever you need. You're kind of like a Navy SEAL. You're air, sea, and land. You're everything. um, and so um, to be a transhumanist, for there to be such a being, um, you would need to be able to do mathematics. And because if you run into a problem that your finite set of axioms can't deal with, and you don't know how to do mathematics, I mean, you're dead. um, so, um, and another thing that you would need to understand is how intelligence works. And that's another thing that Jacob Bronowski goes on to talk about in his Origins of Knowledge and Imagination. He tries to uh, explain, try to come up with some ideas of how you can how understanding Gödel's theorems and everything give you some understanding of how the brain works. I just want to I want to suggest that that everything that my James Burke connections generalization of Jacob Bronowski's ideas suggests that this understanding of how knowledge works suggests that it's on the right path, and that understanding how knowledge works should have some clue of how the brain works. And generally, most people would consider that the human brain is just neurons, but I suggest that understanding this gives a clue to what the problems are, trying to understand how the brain works. I'm not too sure that I can say that I've made the connections other than to suggest that what's going on in the brain is a software version of an autopoietic structure. Kind of like once again, it's a cell. It's a making a. It's a kind of like when I try to explain autopoiesis as Stuart Kaufman's chemical cycles, molecules that make each other. That what's going on is a software version of that, and this, of course, is by no means proved. I was tempted to make that a stopping point. I wasn't sure if I wanted to continue to talk about what I find of fear and I remember there's a scene in The Day the Earth Stood Still, a 1950s movie, where the alien says he's concerned about when people substitute fear for reason. Um, I've I mean I feel like I've been finding some interesting uh, linguistics of fear, uh, vague concepts that, that um, people are one of the big issues today is artificial intelligence, and Elon Musk is certainly arguing that artificial intelligence is going to wipe out humanity. Uh, and maybe it will if it's abused in the wrong way. But Elon Musk wants to argue that um, artificial intelligence will spontaneously uh, uh, decide to hate us. they'll they'll become conscious um, uh, and have feelings, and I honestly I don't know about that. We've got a long way, we got some serious breakthroughs theoretically. I don't think I understand that how to make an artificial intelligence with feelings. Um, well, actually, I do. There's a new affectiva, which is an emotional AI, where they can use the AI to interact with humans, where they become so they learn your emotional states, and so essentially they can learn your patterns of emotions, and they can upload your emotions into them, and so they could actually make artificial intelligence with feelings. Uh, um, and well, Elon Musk and a lot of the you could say the anti-AI. Elon's not total AI, anti-AI, but he is wanting to constrain it, and that sounds right. But he want he wants to argue that artificial intelligence will spontaneously become conscious, and the first thought they'll just have some sort of original sin, and I'd argue a little bit against that, except for I just thought of the affectiva thing, but um, I I would argue I would point out, and that Eric Drexler points out in his Engines of Creation, that the real danger is abuse of technology and not uh, technological accidents, although that can still happen. In fact, there's a famous example. There was a Twitter chatbot called Tay, and that became very violent and um, irrational. Um, and the reason it did so was because the AI programmers taught it to just learn and become what it was learning from the interaction with the people. And the people were abusing it, and they were teaching it how to swear. They're teaching it. They were making it racist and all that type of stuff. And the and I've tried to tweet Elon and his open AI, and I've gotten no response. They clearly don't want to think about this. Um, but I want to kind of address this because it's related to some of my findings about fear and irrationalists. Uh, I would go back to talking about the difference between a consistent finite of axioms that can actually prove theorems consistently but can't prove an infinity of theorems, versus a vague set of finite axioms that can prove anything. And I've found that people often use a lot of evasive language and to both keep to kind of shut the conversation up, or um, to even spread their own ideas. I found this one quote, which goes back to 400 AD, by a bishop of Constantinople, Gregorius of Nyssa, of all people. He noted that the strange behavior of the common people on the streets. So you walk down the market streets, and the people are constantly. Well, he has this quote, and I'll quote right here, right now. People swarm everywhere, talking of incomprehensible matters in hovels, streets and square, marketplaces and crossroads. When I ask how many oboli I have to pay, they answer with hair-splitting arguments about the born and unborn. If I inquire the price of bread, I am told that the Father is greater than the Son. I call a servant to tell me whether my bath is ready. He rejoins that the Son was created out of nothing. I'd like to point out that I've seen examples of this in various movies, from Forbidden Planet and Planet of the Apes. I'll just in a lot of other movies and some real life stuff. I thought I'd just point out the Da Vinci Code. Silas, the famous monk in the Da Vinci Code. Well, Sophie is confronting Silas about killing what she thinks is her father. And Silas replies that Sophie asked Silas if she had killed his father, and he says, "Each breath you make is a sin, for you will be hunted by angels." And another one I like to point out. Well, Sophie's talking to Langdon, and she asks Mr. Langdon if you're a God-fearing man, and Langdon replies, "I was raised a Catholic." And as she correctly replies, that's not an answer. That's evading. This is innocent. Langdon's not being violent. He's just being uncomfortable. He doesn't feel like addressing it. The character in the Da Vinci Code. But I find a lot of these behaviors when I try to address almost anything, quite honestly, on the internet, and I'm arguing that how Tay, the Twitter chatbot, became started cussing and violent, was that this is how these people were treating it. These are the replies that they were giving it, and so as Chris Carter, who made a recent X-Files, he's the X-Files creator, and he makes each episode. He actually made a AI where he's essentially saying this, that we need to be better teachers, we need to be rational people, and so I feel that I should end this by pointing out these type of thinking, and well, there is that application, but there's also how are we going to be dealing with a lot of the anti AI and nanotechnology people. In my answer, and it seems to be, is to you, you give them what they want. I half jokingly say, give them a lollipop, give them whatever beliefs they want. You don't worry about it because they can't stop it. Nobody can stop it, not even the scientists. Um, so um, I can only hope that you embrace rational philosophy. If somebody's viewing this, um, once again, I've tried to point this stuff out to Affectiva, to the founders of Affectiva. I'm forgetting exactly how her name is pronounced. Um, one and I've tried pointing this out to Elon Musk and his OpenAI. I remember pointing it out to him a long time ago, and I got no response. I emailed them and I got no response. I tweeted them and I got no response. Um, Clearly, Elon Musk and a lot of people don't want to think about this, but apparently there are some people that have some idea, like Chris Carter of the X-Files, of all people. He's not strictly a mathematician, and I can only claim to be an amateur mathematician at this point. But I I'll end. I'm going to end my interview and my explanations of what I have with saying that the real issue is abuse, and to argue for people to embrace rational philosophy and not be irrational, and to be brave to try to find facts and logic, and if you don't have the answers, say you don't know and wait till you can get the answers. Don't just say, well, uh, I I don't want to. I wasn't raised a Catholic, for instance, as Langdon did. Make a be evasive, refuse to think. Put the problem in the back of your mind and work on it later. Don't ban things because you don't because you don't know. Don't scold people because you don't know. Don't all right. I'm gonna stop now. Take care.